So graphing a piecewise function. It works for me, so hopefully it works. So the first piece is 1 plus sine x. So 1 plus sine x divided by, you use the division symbol. If you have the newer color edition, it looks fancy. Divide by open paren x, press second math. You will get a bunch of operators, and we are going to select number 5, which is less than 0. I like to work smart. Hopefully this works. We'll just try the first one. Yeah, it works. The second one, cosine x divided by 0 logic, so second math, less than or equal to, which is number 6, x second math, less than or equal to pi, where is pi? And the third piece, sine x divided by, so the backslash that we use in this case is not for division, it's just to specify the interval that is right over here. But make sure you put the parentheses or else it will result in issues. So x greater than pi. Good. We have our 3 pieces. Let's go ahead and graph this. We have to adjust the window. So I'm going to go from minus 2 pi to plus 2 pi. Any thoughts as to why I'm going from minus 2 pi to plus 2 pi?
Because it's sine and cosine graph, and that's the error, isn't it?
Because it is a sine cosine graph and it is going to have a period of 2 pi. Okay, great. What about the minimum and the maximum value?
I would say 1 and 1, but
Close. 1 and 1. 1.
this is the first piece.
First piece, right? Sine pi over 2, negative pi over 2 will give 0. 3 pi over 2 will give so that is going to be 0. So maximum just needs to be 1. Good. Got a whole bunch of pieces, right? Just to be sure, I know the upper limit probably is definitely 1. I don't want to show you the wrong thing. Okay, it is. Okay, now here is the challenge. Now that is the picture. Now we want to draw the pieces properly, right? Now what the calculator is doing, it's drawing everything simultaneously. I believe the newer version, that's a different thing, yeah? Or is it the same?
You have to do that, it's the same.
It's the same thing, okay. So I don't have to feel that. So this is what I want you to do. Look at the picture and draw a graph for the appropriate intervals and put the closed and the open dots appropriately. Yes, no.
I just wanted to ask you to do this right.
Okay, give me a second. So the maximum is 2, not 1, because 2 is right over there. I was looking back there. So it's a good thing we moved it to 2, but that doesn't matter to us. Cassidy pointed out, apparently, we can just get the pieces done right instead of, having the entire curve. So second, no. Y equals the second inequality is 0 less than or equal to x less than or equal to pi. It is the same as saying x is greater than or equal to 0 and x is less than or equal to pi. Yeah? Yes. So in your calculator, x second match greater than or equal to 0, second math over to logic number 1, which will give us and x second math less than or equal to pi and are we good so far? Yes, yes.
Yes, you put it in, can you do it the one way, 0 plus equal to x plus equal to pi? Or do you have to
No,
break it up?
apparently can't do a compound inequality directly, but you can also do it this way, 0 less than or equal to x and x less than or equal to pi. Both are right, because they mean the same thing. Good.
Thank you.
So 3 pieces, right? So first piece, second piece, third piece. So much piece. Okay. Good. So the graph that we graphed happens to be the maximum is 2, so that's awful. Two. That is less than 0, so I'm going to put open dot. Yes. So 0 pi over 2 pi 3 pi over 2 pi, and it's going to keep on going. And we know what a cosine is going to look like between 0 and pi. It's just a shifted version of sine, but 0 less than or equal to x. Yes. So since there is less than or equal to, what happens to that closed dot?
Look at it.
What?
Close it.
It fills, okay. And what is the smallest value that it can take? Pi. No, okay, for y.
1.
1?
Negative 1.
Negative 1. Okay, and that's a closed dot too, because less than or equal to. Yes? And that's 1. -1. And greater than pi starts at sine x. So we know sine pi is 0. Sine 2 pi is 0. Not bad. Okay. So those are the 3 pieces. Good. Where do you see discontinuities? So initially, we said there would be a discontinuity at 0, a discontinuity at pi. What's his name? Doesn't have the phone in front of you. Is he sleeping? You. What's your name?
James.
Who?
James.
James. James mentioned there are 2 discontinuities, 0 and pi. But now, how many do you see?
1.
1. So the second piece builds the discontinuity in first. So I've got only 1 jump. So just by looking at the picture, how many limits do we expect to happen? So initially 2 discontinuities, 2 limits were possible. Now we just have 1 discontinuity. So only 1 limit will exist. The other has to be. No,
It's kind of-
3 letters.
Does not have to.
Huh?
Does not.
Those are 3 words.
Sorry.
D and E.
D and E. But I get the point. So it does not exist. So in conclusion, if I go from the left-hand side, I get 1. If I come from the right-hand side, I get 1. Right-handed limit matches the left-handed limit. So limit x approaches 0, f of x would be equal to 1. Yes. Now the next point of interest would be pi. Limit x approaches pi from the left-hand side would come down here and it would end as -1. Limit x approaches pi from the right-hand side will be 0. Yes. Do they match? No. So good. And last time, I mentioned something. Undefined and DNA are not one and the same. Good. So I have given you multiple pointers. So in finding this limit, there's an important trick or approach that you've got to keep in mind. Anytime you have a rational function, do we agree that this is a rational function? Yes. Anytime you have a rational function, what should you do from algebra?
Denominator.
What?
We have to look at the denominator.
Okay, we have to look at the denominator. That's one. What else?
Doesn't that have something to do with x squared being the same on top and bottom?
Oh, great. So have something to do with x, y being the same. I agree.
Factor.
Factor. So you have to factor always, because when you factor stuff, you can get rid of some of the factors. What do you mean?
Mine? Annie.
Emmy?
Annie.
Annie?
Caitlin.
Caitlin, so Annie, Caitlin, but Annie, all of them were correct. So we will address each of them as we go along. So the book wants you to do something, but I'm going to show you the easier way first, then we'll go and struggle. X times x minus 3. Do we agree?
Yeah.
I pull x out. Denominator, I have x squared minus 9. Could I write it in a different way?
Yeah.
I could write it as x plus 3 times x minus 3. Good. Now, why is factoring important? Had you put 3 in there, what would you get? 9. So 9 minus 9 is 0. Divide by 0. So you think, okay, that's a problem. But if you factor, those two will go away, and you will have limit x approaches 3, x over x plus 3. Agree? So plug in the limits, and what do you get? Or since you don't have any problems, well, you do have a problem at -3. Do you agree? If you plug in -3 here, you have -3 plus 3, which would result in 0. But we don't care about that -3 because we are looking at limits x approaches 3. So we just plug in the values. 3 divided by 3 plus 3. And what do we get? 3 over 6. Huh?
1/2.
1/2. That seems odd to me. That makes sense. Is there something special about this one? Ah, never mind. I'll find someone like you. I'm confusing something that's no one got time. Never mind. A limit x approaches 3 ends up being 1/2. Here is a question. The limit directly exists. So what does it say about the one-sided limits from the right and from the left?
They're coming the same point.
They are the same, right? Since we know that the limit exists, limit x approaches 3 plus, f of x will be 1/2, and that would equal to x approaches 3 minus f of x equal. But good. Now we're going to take a tabular approach because I'm quite sure that Riverside is going to make you do this. But anytime we are evaluating a table, what function did I say that you should use in your calculator? If you want to evaluate a function with multiple points. See, I'm going like this. No, this. Tabular approach. Tabular approach. Huh? What enable? A table, okay. So we use the table and table set options. So this is what I want you to do. So you understand the concept of limits. Of course, I can't exactly put the value 3 in there because you have divide by 0. I'm going to start at 0. 1, 2, 2.9, 2.95, 2.999. Good enough. And over there, 3.001, 3.01, 3.1, 3.5. Good. And I would like to evaluate the limit at 3. So I want you to evaluate the function x squared minus 3x divided by x squared minus 9, which is f of x, using your calculator. So I would like each of those values. Second day of class, I showed you how to do this with your calculator. So, give you some time, let's see what you get. So, what do we get when we plug in 0? 1. No, 1 over 3. And when we plug in 1 over 4, plug in 2 over 5. In decimals, this would be point. Do I have it backwards?
Isn't it? That's 0, yeah, that's 0. Yeah, that's 0.5.
Never mind. 0.
0.25.
0.25.
0.4.
0.4.
0.4915.
0.4915.
Yeah, that's a fraction.
0.4958.
4958.
And then 0.49917.
0.49917. Over here. Before we go.
0.50008.
It shouldn't be numerical.
And then 0.50083. 0.5082. 0.53846.
538.
Yeah.
Okay. So I start somewhere from the left of 3. A grade of zeros to the left of 3. And I'm getting closer and closer and closer to 3. Do you agree?
Mhm.
So 2.999. What happens to this value? It's getting closer and closer and closer to 0.49917.
Mhm.
When you start from the right hand side at some arbitrary value, so you get closer and closer and closer to 3, but not exactly 3. So 3.001, it's close to 3, but it's not exactly 3. What is happening to the value of f of x? It is getting closer to 0.50008. So from this side, it is approaching 0.499. From that side, it's approaching 0.5. So what should lie in the middle?
3.
Huh?
3.
Well, 3 lies in the middle here, okay. So what should lie over there? 0.5. Agree? So that would be the limit as you approach 3, you get 0.5. Does that make sense? So that matters. Good. Are we clear? Okay. So first question. What is that called?
Difference
Difference quotient, okay. I know just by looking at it that there is a difference quotient of a function. But we don't have to get into that here. I believe it should be 2 plus x raised 6 minus 32x divided by 6. Something like that. This is very closely related to derivatives, or the definition of derivatives. Put A star, we can verify this later. Now, how do we simplify difference quotients? Expand and get rid of common terms, whatnot. And I always said at the end of the day, when you do difference quotients properly, the original function will get cancelled. And there is another condition that would happen. The h's will get cancelled. The numerator h and the denominator h would go away, and everything would be PG. But no, I don't have that, right? Because 2 plus 0 would be 32, 2 raised 5 minus 32 divided by 0, right? 0 over 0 is not 0. It's called an indeterminate form. So we can't just put 0 over 0 as 0. That's a problem. You may say, well, I know the concept of difference quotients. I can expand this out, and eventually the h's will get cancelled and everything would be fine. I can apply h approaches 0. But what is the problem with that?
Yeah.
Huh? Do you follow my question? So right now we will get 0 over 0. So we are in a predicament. And I have mentioned in the past, and you know, if we have a difference quotient, the h's will get cancelled. Yes?
Yeah.
But if you simplify this, the h's will get cancelled. And then nothing would be a problem. But what is the issue with simplifying?
You would have no variables. You would have no variables.
I would have no variables, but I've got h here. Right?
So wouldn't it cancel?
It will cancel, but something else. Do you really want to sit around and boil that out?
No.
Even though we know the Pascal's triangle thing that I mentioned earlier, we don't want to do that. So the numerical way to do this is to use a table. When you put this in the calculator, you can use x, you don't have to use h. So difference quotient. Some negative number. I'll start with negative 0.25. Now, what are we approaching? 0. The next one, going to jump to negative 0.1. Give me a good number that you'd like to try. We're approaching 0 from the left.
Negative 0.02.
Negative 0.02. Why not 0.01?
I don't know.
How about negative 0.001? Right? One more thing, we could go up to 0.0001. Good. So I'm approaching 0 from the left hand side. Now I want to approach 0 from the right hand side. I'll start at 0.25, 0.1, 0.02, approaching 0 from the right hand side, 0.001, 0.0001. Good. We know how to evaluate this, so make use of your table. That would be our function. So we plug in all these values and let's see what we get. I take that back. The function is very simple. It is 32. Any thoughts as to what the limit is? 80, so I'll call this f of h. So. So what would be the limit from the right hand side?
80.
And that should equal the limit from the left hand side. So what did we get for negative 0.25?
62.348,
Negative 0.1,
72.39,
negative 0.02,
78.416,
negative 0.001,
79.92,
negative 0.0001.
79.992,
On this side, 0.0001,
80.008,
0.001,
80.08,
0.02,
81.616,
0.1,
88.41,
and 0.25,
102.66.
102.66. Did we get that? Yes. So 0 is right here in the middle. As you come from the left, as you approach 0, the value starts at 62.348 and it approaches 79.992. From this side, right hand side, if you approach if you approach 0 from the right hand side, as you get closer and closer, here it gets to 80.008. So whatever limit that we have for 0 has to lie between 79.992 and 80.008. So what number could that be? Easy, you guys have the answer. Yet hesitation. 80. So that is how you find the limit. I had a question. What's your name?
Yahira. Yahira.
Yadira or Yahira?
Yahira.
Yahira. So the question was, should we find the derivative of this? And I wrote very closely related to derivatives. The answer is no. So we will have a function and the objective to find the derivative, I'll say that for later. So on our way to find the derivative, the first step would be to take the original function, come up with a difference quotient and find that limit h approaches to 0. And we have to use a process like this to come up with the final derivative of the function. That's a lot of work. Do you agree? So that's painful. So there has to be an easier way, and that's where rules of derivatives and such come into play. So this is an intermediate step to finding derivatives. And it has a meaning as to why it's related to derivatives. I will save that until 2.4. So function, limit, derivative. Good. I have students ask me, well, it's a lot of work, starting at some value, going all the way closer and closer to 0, evaluate all of those things with Weber sign. Sure, you will have to do. But is it necessary then? We get the idea as to why this works, yes? Is it necessary to evaluate the way we're doing? No. Why not, Nate?
I was just shaking my head no. I don't know why.
Okay, do you follow my question? So I started here, getting closer and closer to zero. Started there, getting closer and closer to zero. Lengthy process, right? Webside's going to do the same thing, start with a bunch of negative values, bunch of positive values, and then you find a limit. My question to you is it necessary to evaluate all those values now that you know the concept of limits?
No. Can't you just do the two that are like right?
Mhm.
Exactly. So you can just pick numbers that are very, very close to zero. So here is an example. Limit x approaches zero, x raise x. Let's find the left limit also. May not work, but we'll see. So you don't have to pick all of these values. I'm just going to pick be lazy. Those two. Why to make myself happy in some way. Good. Let's try and see what happens. So just two values. Negative 0.001, negative 0.0001. So this is a good problem, and I put this because I knew that this is not going to work. So you guys tried this in the calculator. What did you get?
Error.
Error, error. D. You can put a star here. This is related to another concept that we will see later on, which is implicit differentiation. So when you come from the right hand side, 0.001, what did you get?
0.9991.
0.9991, and then 0.0001.
It was 0.9931 for that one, and the next one above that was 999.
So this side, error, right? But going from this side, I am getting closer and closer to 0.9991. If you took one step further and just put 0.000001, you will get 0.99999, which is simply 1. So the limit is 1. An even easier approach to get the limit is, instead of doing all this, just plug in 0.00001, and then you will get 0.99999. That will be your limit. Does that make sense? So does a limit exist in this problem? No. Because the left side doesn't equal the right side limit. Okay, that is a good place to stop.